Today I'm going to start working on a project to build a power feed for my round column mill. Alright, so the first piece that we're going to make for this round column mill power feed is this L-shaped bracket. And this mounts to the cast iron bed of the mill and provides a place for 3 out of the 4 standoffs for the motor to mount. I'm going to make it out of 2 separate pieces of steel. And what I'm going to do is I'm going to actually mount these to the bed in 2 separate pieces, and then I'll go in with my TIG welder and I'll TIG up these joints to make sure that once it's welded, it's nice and square and lined up and everything. So I've got the first piece here. It's already squared up. I've got it blued, and I've got some sanity layout lines on it. And it's going to represent all these key points, right? All the holes, the place where I'm going to cut it. And so notice here how it's actually 2 different sizes, right? So this is almost true to size, but it's a little thicker on the top half than it is on the side to achieve the dimensions I was going for. And so what I'm going to do is I'm going to take this whole bar down to this nominal dimension first, and then I'll go through, drill all these mounting holes here and counterbore them, and do that all in one setup, one operation. Then similarly, I'll come back and do all these side-facing holes and get them tapped. And that's where the mounting posts are going to mount. And again, I'll do that all in one setup. Then once I've done all that, I'll come in with my cold saw, I'll cut this, and then this left side piece that'll go down here is going to get shaved down to its narrower width. So let's head over to the mill and let's bring this down to the 632 thou. As I get started here dimensioning this block, quick little channel update. It's been crazy busy with work and life, and anybody that's been watching my shorts knows that some of this footage is already almost a year old. I haven't had much time to play in the shop, let alone edit or cut these videos together. So apologies for that, but I hope you enjoy what you're seeing today, and maybe it'll give you some ideas if you have your own round column mill and you want to add a power feed. This might be a way that you want to do it. I will say that I am not an expert in machining, and I'm not going to go into a lot of detail about the setups here or what I'm actually doing in these operations. There are much better channels out there with much better educational content that you can use if you're just learning this trade. In particular, Blondie Hacks, Joe Piezinski, and ABOM79 have some really good educational content out there for various different levels of machining. You can see here that I've added a scale on each side of the block. And what that's doing is giving me just enough clearance for the drill bit to pass between the parallels down there. I did not have narrow parallels at the time. I do now. And I did mic these scales first before I use them as shims, and they are extremely close in thickness. So no worries about maintaining my center line here as I did this. was at this moment I realized I forgot to drill the side holes while I still had it in one big bar. So, 2 setups, no big deal. I'm adding some chamfers here to help with the welding later. You'll notice in the following test setup, the chamfers aren't there yet. I'm showing these videos a little bit out of order just so I can get all the milling work out of the way. So what you're seeing here is off camera I 3D printed a drill alignment jig. I used the existing CAD model for the L bracket to build this jig, and this allows me to get the holes in the exact spot I need on the cast iron milling table, so that when I assemble everything together we get perfect alignment. It's hard to see from this angle, but the jig is actually quite thick, and that helps me keep the drill perpendicular to the surface as I'm drilling as well. As I mentioned before, I forgot to take some footage of tacking this up while it was installed on the table. Sorry about that. But here you can see I'm just going to take it all together, and then in the next set of clips, very brief set of clips, I'll clean it up, and then we'll look at the final assembly. Well, here it is. You can see there's a little bit of weld undercutting there. I missed. I should have filled it just a little bit more before I cleaned it up. I thought I had enough excess material there though. But this is all ready to go. It's ready to assemble. It was kind of hard to see in some of the prior clips, but I did add a very generous chamfer on those corners so that when I welded it, I actually filled it with multiple layers and got a nice solid chunk when it was all said and done. And then once again, this is not the final assembly hardware. This is just for test fitting right now. I did eventually replace these with some standard M5 cap screws. I'd like to credit the YouTube channel Mr. Mechanical for the inspiration on this design. In the next set of videos, I'll show how I chose a toothed pulley that's the same size as the micrometer dial on this handle over here, and I'll use that pulley to drive the lead screw. Mr. Mechanical's power feed videos are linked down below if you'd like to check them out. And that's all for now. If you like what you saw, please like and subscribe. And thanks for watching as always. Until next time.